Hello, my name is Christian Mullins, and this is my 460 hydraulic case study. The machine that this case study is off of is a Komatsu WA430-6 wheel loader. The company is AIS Construction Equipment. The owner of this machine is CRC, which is AIS's rental division. The serial number on this machine is A41008, and the hours that this pump failure occurred on this specific machine is 2,667. The complaint for this machine was that the hydraulic oil is overheating and will not cool down while the machine is running. The diagnosis of this machine: first, the technician ran the machine to see what was happening. While controlling all controls on this machine, found nothing wrong with that, but did find that the hydraulic oil got hot and stayed hot when in neutral position and never cooled down. The next step was checking all the pressures on the machine. Like stated earlier, this verified that none of the equipment itself had low pressures. They found that at wide open throttle in neutral there was 200 kilograms of pump discharge pressure. This was due to the swash plate being open, and the pump was not able to de-stroke during this, maintaining a swash plate angle. The technician then found a PSN for an updated pump and adding a filter screen in before pump to reduce contamination. So the cause of the problem is that the piston hole portion in the servo piston got abnormally worn due to contamination, causing the pressure to rise, making it so that the swash plate angle remains while in neutral. And this makes it so that the pump never de-strokes, making it so that there is a flow on the pump side, creating heat. This is the failed component. On the top is the outlet hole for the servo piston, and then on the bottom is the inlet hole for the servo piston. The wear is very minimal, but due to the discharge pressure, it shows that this was the problem. So for the correction, the failed loader pump was replaced with the new updated pump per the PSN. Since the whole pump would have had been taken apart to replace the servo piston with a piston with the correct surface hardness, that is why the whole pump was replaced. So for the servo piston, there was an update on the surface hardness from HV600 to HV700. The heat treat process was changed to increase the resistance to abnormal wear from foreign material. The process was changed from tough drying to gas nitrocarburizing, and the surface hardness was increased 100 HV. The new updated pump number is P7MO2639 for the loader pump. For the strainer, this is where the PSN showed that a strainer needed to be added. The strainer was added. It is a 1400 mesh type strainer. It is added to the self pressure circuit for the swash plate control of the pump. This allows for any contamination going to the pump to be filtered out, preventing the servo piston from failing due to abnormal wear from contamination like it did in the previous loader pump. And this makes it so that the hole does not get abnormally worn like it did before. This is the service information that I was sent by AIS on this machine. As you can see on the left side, 3 rows down is the testing pressures of the machine when the failed pump was in. You can see that the torque converter stall was at 1,710. The hydraulic stall was at 2,160, and full stall was at 1,645. The working pressure was at 310 kg. The work equipment diff pressure was at 15 kg. And then on the right side, you can see the process of the strains being put into the machine, or the strainers being put into the machine. And then on the bottom, you have the new updated PM Clinic, which shows that the torque converter stall increased to 1,892. The hydraulic stall pressure was increased to 2,190, and the full stall was increased to 1,750. And then it relates to the work pressure was still the same, and the diff pressure was still the same. For this is the PSN that was given for this machine. The subject fits the description that was dealing with the complaint. The application is it fits the serial number range for this machine. And then the description, the piston hole portion worn from debris and circuit, which had entered into the servo piston, abnormally worn piston hole, leaks servo piston control oil, and pressure is hardly able to rise. This makes it so that the swash plate gets fixed on maximum side, and the large pump flow rate continues, which may cause overheating, which in our case it did, and that is why the filter screens got added and the surface hardness of the servo piston got increased, and also the pump was completely replaced with an updated pump. I'd like to give a special thanks to Steve Sutton at AIS Construction Equipment for supplying the loader pump and work order information for this project. And that is all. Thank you.